Hi guys, hope you will be doing well. So this is the third class of our system design, where we will see that in the last video we see what is monolithic architecture, what are its advantages, disadvantages, how to scale it. So check out that video. Here I will talk about what is microservices architecture, what are the components of it, how these components work, real world examples, how to transfer a monolithic to microservice architecture, and what are the challenges in microservices architecture. Let's begin with the what is microservices architecture. So microservices architecture is an architecture or a blueprint where we divide our application into a small units that are known as services. Remember, we divide our application in what into small units. These units are known as services, and these services communicate with each other with the help of APIs or network calls. And furthermore, these microservices also can develop and scaled and deployed independently. Remember, this was the only core feature that we desire in monolithic architecture, because monolithic architecture do not allow us to scale a single module, to develop or to deploy a single module. But in microservices architecture, we can develop um, a particular service. Why? Because we have a separate code base for each microservice, and we can also deploy or scale it because each service is deployed separately. Furthermore, not as each service has its own code base, so we can develop each of the service in any language according to other business case. Like we can develop user service in Ruby on Rails. Similarly, we can develop inventory service in another framework like Node.js. Along with that, these services are loosely coupled. Remember, in monolithic architecture, services or modules were tightly coupled in a single code base, but here these services are loosely coupled, and we will see in the later part of video that how we achieve loose coupling. For example, we use event driven architecture and event bus message queues. Furthermore, each service has performed single business operation, means the single responsibility principle is being applied to each order service. So yes, this is one of the principle that we need in software engineering. Now let us discuss what is the why of microservices, why we use microservices architecture instead of monolithic architecture. So the simplest answer is that although monolithic architecture provide us the benefit of faster development and reduce our budget, because we do not have to make decisions and our operational complexity is reduced, and we have a single team, so it is a budget friendly. But monolithic architecture fails in two things that this microservices architecture provides us. The first one is independent development and deployment, and the second one is independent scaling. Means in monolithic architecture, our services and our modules and components are tightly coupled, and we cannot develop or deploy them or scale them individually. Why? Because they are present in a single code base or in a single unit. Whereas in microservice architecture, we know that we divide our application into an individual unit known as services, and yes, this service can be independently developed. Why? Because it has its own code base, and you can write it in any framework, and we can deploy it on any platforms or cloud hosting platforms like AWS, as we can scale it with the help of techniques like horizontal scaling. Let us discuss that what are the components of microservices architecture. Well, in monolithic architecture, we know that we have a load balancer and then instances and centralized database and Docker for deployment and Kubernetes for orchestration. But in microservices architecture, first of all, we have to understand that our request goes to a single entry point that is known as API gateway. That is known as what? API gateway. So after API gateway will do what? It will direct our request towards the appropriate service. So basically, what do API gateway do is that API gateway is responsible for authentication, for logging, for rate limiting. So consider user login to our large scale application like Amazon. So what happen is that API gateway will direct our service to the microservices, to the user service, to what? User service. So this is the second component. Now in this user service, it might be possible that millions of users are going to log into our into the Amazon application. So to handle large scale traffic and to distribute it efficiently, we use load balancer in a service so that to enhance availability, throughput and reliability. So here comes our load balancer that distributes our traffic to a healthy instance. Okay, so this is our a third component of microservices architecture, that is known as load balancer. So now so consider that same use case of logging in our large scale application like Amazon. So what happens is that our request has now successfully approached this healthy instance. Now what happens is that we need to check that whether this email or password of this user exists in our database or not. So yes, before making a call to the database, as I said earlier that millions of users are coming, so it is best approach to utilize a cache. So what will be the advantage is that it will reduce the DB load. Okay, so here comes our fourth component, that is known as cache. Okay, so and it is possible that in the cache that email and passwords for that email and password is not present, so there will be a cache miss. So what happens is that we will now send our request to the database. So remember, as I said earlier, that there is a one database for each service. Okay, so here comes our fifth component, that is a database. Okay, so yes, after this what happens is that it might be possible that we need to communicate, as I said earlier in my previous section, that what is microservices. We divide application in multiple services. Now it might be possible that one service, for example, in the use case of buy now, that what happens is when the user clicks on buy now, then what we have to do is that we have to first of all do payment. We have to do what? We have to do payment. Yes, and after successful payment, what we have to do, we need to communicate to a service known as inventory service. Why? Because to update the product. Okay, so yes, this is the use case. So it might be possible to that services need to communicate. So for to solve this issue, we have our sixth component, that is known as service registry. That is known as what? Service registry. So what happens is that it stored the addresses of um, different services, and when service any service need to communicate with another service, that service request this service discovery or service registry to give the network address, and then that service is able to make a call to another service, like payment can make a call to the inventory service with the help of this service registry. So yes, here I have discussed how many components. Here comes 6 components. So now it is possible that, so keep in mind that there are two types of communication between services. The first one is synchronous communication, and the second one is asynchronous communication. Synchronous service is that service has to wait for the reply from another service. And for example, consider an example like again this payment service. As I said earlier, in the buy now use case, after getting the network address of inventory service in buy now in order by order product use case, then what happens is that now payment service successfully calls this inventory service. This inventory service will do processing, like it will update that product in its corresponding database. Then while this processing, our payment service is doing what? Is basically waiting. So this is the bad user experience. But yeah, asynchronous communication, one service has to wait, has to do what? Wait for the reply from another service. So it is kind of a block. And so to avoid this, we usually adopt asynchronous communication, and also it is a good practice because it helps in reducing the coupling between different services. So how do we achieve this asynchronous communication? Well, there are different methods, but what I am discussing here is event-driven architecture. That event-driven architecture utilizes a queue that is known as event bus. That is known as what? Event bus or message queue. So what happens is that, consider that same use case of payment, like payment service has successfully called this our inventory service, and inventory service then update the product and send the request back to the payment service utilizing service registry. Then what happens is that payment service will now save this order with the status of paid. So after creating this record, it will push that order to a queue to this event bus. So what happens is that after pushing this to the event bus, our different services like notification service and shipping service are basically subscribed to this event of pushing this paid order to the queue. So our notification service and shipping service are, as they are subscribed to this event. So when broadcast occurs, when there is publishing or broadcast occurs, then what happens is that this notification and shipping service will receive this broadcast, and they will do their responding actions. Like notification service will simply sends notification email where SMS, whereas shipping service will do what? It will simply ship the product at the customer home. So hope you, so now we have covered the how many components. So in this way we will achieve asynchronous communication. And remember, this event bus is the same concept as as if you know JavaScript. Then in JavaScript we have micro task queues and macro task queue. It is same like that, and it helps in reducing the coupling. So till now we have studied the components of API gateway, then users, then microservices, then load balancer, caching, database, and service registry. And now I covered what message queue. So there are two more. First one is that for deployment, as I said earlier, that each service like this user service can be deployed independently, so for deployment we will do what? We will encapsulate this whole service and consider it as a one box. You can say it as a container in Docker. So we will do what? We will make containers of our services and deploy those containers, so it will happen faster deployments. And in future, if we have many containers, we can use Kubernetes for orchestration, like for managing multiple containers, like starting and stopping and restarting. Okay, so this is our eighth component, that is deployment and orchestration. So now comes the last one, that is service, and that is resilience and fault tolerance. So what do this resilience and fault tolerance says? That we usually put a circuit breaker, or what is circuit breaker? You know that this word is similar in our houses, that in our houses we have the circuit breaker. What do it do? It simply check that if the voltage are higher, then it will cut off the light in our home. Same is the case in here, that circuit breaker will actually monitor the response of service. For example, API gateway direct the request to the user service, but let's suppose there this user service do not respond, or so what happens is that again request will occur, so there will be retries. So it is might be possible that and this user service is slow or shut down. So basically we need a mechanism to tell to API gateway that stop making requests for particular time as I am healing up. So this functionality is done by circuit breaker, that it says to API gateway that since this service is not responding, is slow, so please request me after a particular amount of time. So these are the 9 components of microservices architecture. Discuss that what is the real world example of microservices architecture. See, microservices architecture is everywhere, from the banking services to the e-commerce platform to the Uber or even the video you are watching on YouTube is also made on microservices architecture. But remember that these platforms like YouTube or Uber or Amazon e-commerce application and banks, they do not come to the microservices architecture in a single day or from the beginning. No, first of all they started as a monolithic architecture. Then once their users started growing from millions to billions, then they proceed towards the microservices architecture. So now let's discuss the example. Now let's consider one example of e-commerce platform like Amazon e-commerce application. Now let us take one example from the e-commerce platform that of Amazon e-commerce application. So Amazon e-commerce application is made up of many individual services. Remember that these services are independent and loosely coupled and dedicated for a one business need. For example, like in Amazon e-commerce application, there is a user service that towards manages the user, like login, logout, and their preferences so that it can give personalized user experience. Similarly, this application is also made up of a service known as a, a search service to search products so that products can be indexed and searching can be made fast for millions billions of users. Similarly, we have another service known as catalog service that manage product listing on the page and so that listings are accurate and easy to access. Similarly, another service of Amazon e-commerce application could be cart service so that users can add items in that cart. Similarly, we have a lot of services that when combined form an Amazon e-commerce application. Let us see that what are the steps or how to transit our monolith architecture to the microservices architecture. And see, it is the set of process and we have to do it step by step in a sequence manner. So first step is that we have to analyze monolith. I will explain you these concepts with the help of first real world analogy of a restaurant, and then I will discuss each step by considering a software world example. So before moving to the first step, let us understand monolith architecture by considering a one large restaurant where everything is occurring in the same building. For example, order taking and delivery and cooking, everything is happening within the same building. So same building means one single unit. Remember, in monolithic architecture we have a single unit that is deployed and that is developed. So yes, first of all we have to analyze our monolithic, that here we have to ask questions from ourselves that what currently we have, and our goal is to understand or understand the map before rebuilding before rebuilding or transiting to the microservices architecture. So now let's consider this as uh, Amazon e-commerce system, and so it consider it as Amazon e-commerce system. And we know that Amazon e-commerce system is actually a microservices architecture where we have multiple services, as I told you in my previous section of the video, that user service for managing the users and search service. So yes, we have to identify in this step that what each component is doing, and we have to identify this coupling between different components. We have to identify what each component is doing, and so that we can identify the business need or business capability of each um, component in monolithic architecture. So now, after identifying that what are the components, what are they doing, and then we move towards the second step, that is known as split the business capability. Split the business capability means, since we have identified the components, identify bottlenecks, now we have to understand that what each component is doing, and if two components are doing same business function, that we will accumulate it and make it a one service. For example, like user login and user logout, and authentication and authorization for a user. All these things belongs to a user, so that is why we will accumulate all these login, logout and authorization functionality into a one service known as a user service. Okay, so now consider again that restaurant where we have everything in one building. Then we have to identify that yes, in previous image I have written the delivery within this order taking, but after analyzing the process of delivery, and the manager or the restaurant owner identifies that no, this delivery is a separate business function that needs to be considered as a separate entity or separate microservice in technical terms. So we make it as a separate individual unit. Similarly, in case of software world example, we will have different services, and remember, each service is specialized and dedicated to perform a single business function or single business need. And remember that in between these services we have loose coupling. We have what? We have loose coupling, no tight coupling like in monolith, but loose coupling in microservices architecture. So hope and you understand that first of all we will analyze our monolith, that what are the components. Second of all, we will um, create a boundaries of ownership in the second step, that what each component or what each individual unit will do, so that each unit performs a single business need or business capability. After these two steps we will since after these two steps we have microservices understand, and we have separated out microservices. Now come towards that how these microservices will communicate with each other. See, without communication, and these microservices are useless. So what we do in this step is we will uh, craft the request response format of APIs, that what will be the request format, what will be the response format. So we will design all these APIs, and so yes, similarly in the software world example, uh, we will again craft the API design. For example, this order component needs to communicate with the inventory component. Then what will be the request format, what will be the response format of API. It's the fourth step of transitioning from monolithic to microservices architecture is the strangler pattern. Strangler pattern says that instead of making a single migration from monolith to microservice architecture, Instead we have a gradual replacement. We have what? We have gradual replacement, and so that our transition becomes smooth instead of immediate transition. So what we do is that in the week one, in real world analogy, what we will do is that we will separate our room of order taking in that was previously present in this our restaurant building. We will separate it into another building for uh, dining. So what happens is that our users will come to the dining center or single table, and this table or dining center will direct these users to the either order taking or to the different scenarios like for delivery. So yes, this is actually what happens uh, in triangular pattern, that we do transitions step by step in a gradual manner, so that uh, our production do not break. Our production does not break. Our production of monolith does not break. Similarly, in the week 2, what we do is that in that same restaurant we take another room like cooking, and make it a separate service, and so that these two services can be developed, can be deployed, and can be scaled independently of the other rooms or buildings. Okay, so yes, same happens for the software system as well, that in Amazon e-commerce application, what we will do is that we identify that in inventory component millions or billions of requests are coming, so we separate this component, or you can say it service, because now it is a service. We separate this service from our monolithic architecture, and created a separate service so that it can be independently deployed, developed, and scaled, and uses this technical term known as API gateway. As I discussed in my previous section in the components part, that it is the central point of all the requests, and it will handle authentication, logging. Now let's move towards the so after analyzing our monolith, after splitting those components by business capability, or you can say identifying microservices, and then after crafting APIs, and then having a gradual replacement, now move towards the fifth step, that is known as service discovery. See, and we have two services. If one service needs to communicate with the second service, and there must be a mechanism. If one service directly communicate with the second one, there will be a no use of microservices architecture, because it will result in tight coupling, and we want to reduce this tight coupling. So what we use as discussed earlier in my components section of the video, we use this service discovery component of the microservices architecture. What happens is that, again, consider real world analogy, that users will come to the dining center, that we want to this user say to the waiter that I want to eat one salad of price 10. Then waiter at dining center will direct that user to the order taking building. And then after that, order taking building will direct that user to the another room, so that so that the customer can identify the cooking building. Okay, so yes, see this service discovery, and now we see this service discovery in the software world, that suppose customer come and click on the buy now button. Then what happens is that, first of all, you will see that request will go to the first of all payment service. Okay, First of all, payment will be created, and after creating payment we need to communicate with the actually a inventory component. So here this service discovery will help us that payment service will request this service discovery to return the network address of inventory service, so that the product details can be modified. So as I told you in my component section video, that yes, this will return the result to the payment service, and payment service will easily call the you say is to the actually inventory service. So yes, this is actually we have to create a service discovery. It is just like a book. So that efficient or dynamic communication, what is the goal of enable service discovery step is nothing but the seamless or dynamic communication between and these microservices. Now after fifth step we come towards the sixth step, that is known as a centralized logging and monitoring. See, for efficient debugging we need some tool, like as I said in my components section of the video, that we have circuit breakers. So yes, we use these different logs, metrics, alerts, traces, so that we can observe and track what is the purpose um, of utilizing circuit breakers or centralized locking. The goal is to observe or track the request. Okay, to observe and track the request, and also that if there is some failure, then we can use some mechanisms like circuit breaker to handle the system failure. Now come towards the second in the seventh step of migrating is standardized security and shared concerns. See, in Amazon e-commerce application, all the services and like payment service, delivery service, all these should have same all these services should handle the authentication with the same phenomena like JWT or OAuth. Why? What is the goal? Goal is to have a consistency across all services. And now come to back towards our real world analogy of restaurant, that in the restaurant, if one building of payment is having the design on the walls of like uh, paper and paper design, similarly that design must be in the cooking building as well. Why? So that consistency should be maintained, and it should feel pleasant. Okay, so yes, after having a standardized security and shared concerns means actually a secrets or audit logs, that we should retain secrets or audit logs, so that in future uh, we can monitor or control our application. So now come towards the eighth second last step is to now come towards the deployment side, that to ensure that our deployments are reliable and smooth. We want smooth and reliable deployments. For this purpose, we develop CI/CD. What the CI/CD means: continuous integration, continuous and deployment or delivery. So what happens is that we actually utilize this principle, that we develop in each code base for each microservice, then we do performs tests like unit tests or system tests. Why we perform these tests? So that our new code not only breaks the this service, but also should not break the functionalities of a whole system. So after all these tests are passed, we make a build and then we deploy it so that our deployments are smooth and independent. So after, and we use Docker and Kubernetes for this purpose, as I told you in my components part of the video. Now come towards the ninth and the last part, that is iterate and improve. See, microservices architecture is never completed, is never, you say that, never ended. Why? Because it is continuously evolved. We continuously measure latency, we continuously measure throughput, we continuously measure the failures of each service. Why we do so? So that we can refine it in the future, so that we can identify that where there are bottlenecks, so that we can minimize those bottlenecks. In this way our architecture keeps on evolving. So yes, these are the 9 steps of transitioning from monolithic architecture to the microservices architecture. First challenge is, yes, managing services requires internet. So internet is one of the issue that we require internet for our communication. Now after in the restaurant analogy, what waiter has to do is to they have to call. Yeah, okay. So this calling will be a overhead, but in software world example, what happens is that network call will be done. Okay, and why it is challenging? Because network may be reliable, sometimes we have internet, sometimes not, and services can be slow. If network is slow, services can be slow, and we require circuit breakers for fault tolerance and resilience. Key challenge, that is network latency. Latency means time to send the request and time to receive get the response from the service. So network calls take time. Okay, so if take more time, then user experience will be affected. So for example, request is made by the user and time taken by the request to go to the service and to come back is known as latency. So in a real world analogy, what happens is that your customer gave the order like one salad, and then call will be done to the kitchen, and after that the kitchen chef will call to the package service to package the order, and then packaging will call the delivery to deliver that order. So we have more steps, more time. Okay, latency will be increased, time will be increased. In software world example, you click on buy now button, order service will call payment service. So see this time, milliseconds, all these milliseconds will be aggregated, and so user experience will be affected. And why it is challenging? Because user experience will be affected. And remember, see, this latency is not our control, network is not in our control. Third challenge, that is data consistency. Consistency means what? Synchronization means same state must be present in all databases. So since different services have different database, so due to the failure, data may be outdated. So for example, in in service A database, data may not be the same at same time in all services. Why? Because of the failure. And in real world analogy, for example, a customer requests the dining center that whether pizza is present. Counter says yes, available, and other says sold out. So there is inconsistent information, customer will be confused. In software world example, inventory is showing that zero, no product is present, but order service is showing the stock. So what happens is that order will be created, but inventory service will say that I cannot update the stock because I have zero stock, it will result in wrong orders. And why this consistency is challenging? Because updates needs to be done in different databases, and failures lead to the out of sync data, and we need eventual consistency. And this eventual consistency patterns include saga pattern or 2PC. These patterns we will discuss in the future. Second last challenge, that is maintaining consistency across services, is also a difficult task. So keeping data across multiple services is also hard. For example, order is placed. Since order is placed, we have to update order DB, we have to update payment DB, we have to update this notification or analytics DB, and all these DB must be having the same data. In real world analogy, so you order a salad, you have to update this notebook, and then this notebook, and then this. We need to update order DB, inventory DB. So it is difficult to keep sync all of the time, because since network is unpredictable, services can be unpredictable. So why it is challenging? Because as we have more services, so we need to manage more updates across databases, and partial updates may occur, which results in inconsistency. And yes, we have to make complex coordination across multiple services. Last challenge, that is distributed transactions. Distributed transaction means transaction across multiple databases. For example, order DB means no single AC transaction across all. We need complex strategies like Saga or 2PC that we will discuss in the later videos. In real world analogy, consider same restaurant is booked by a hall, is booked by a marriage. Then since it is booked by marriage, then those who are going to do marriage will give payment, but consider that caterers refuse, that we cannot do catering for this event. Then what happens is we need compensation logic. So yes, it is hard in microservices architecture. In software world example, I considered that we create the order, we charge the user, but stock service fails. What happens is we need to do refund as a recompensation logic, and we have to cancel the order. So it will add more operational complexity. And why it is challenging? Why distributed transaction is challenging? Because we do not have a single transaction manager. Rollback is not automatic. We have to do it manually, and then it requires sagas pattern, and compensating and idempotency will be required. I hope this video helps you. If it helps you, please consider it giving a like, and if you want to have future updates about system design and lectures, please consider subscribing my channel, and I will meet you in the next one.